Hi, my name is Tai Maaz, and today I'm going to be talking about the components of a comprehensive nutrient management plan as well as the importance of soil health. So I teach two courses, Tropical Plant and Soil Sciences 450 and 650. Those are both nutrient management courses. We are always looking for farmers who would like to participate and have our students develop a nutrient management plan for your farm. And so if you are interested in that, I'm going to go over the components of the nutrient management plan, and I'm going to show you a tailored system or a tailored plan to an orchard system. I'm going to use coffee as an example because I spend a lot of time working on a coffee management plan. And then Andrew's going to pick up on that, and then he's going to present you the macadamia nut side, just to give you a model. And then also talk about the importance of soil health. So again, I want to go over the components, and so I'm going to use this as an example. So this is a Mānoa coffee orchard. It's for boutique coffee production. The student who led this is Julie Burden. She's also going to be roasting the coffee for sale, and she developed this as part of my upper level course. And so I'm going to begin with system description. And so this information you may know intimately, and so you probably know your systems very well in terms of your site description, your cropping system, your climate. But the reason why we cover this in the nutrient management plan and why it's important as crop consultants is because sometimes we pull information in from other systems and other regions, other parts of the world, and so we want to know the context to make sure that we're pulling the right information for nutrient management and tailor it to what is most appropriate for your system. And so you can see here it's a little bit small, but we have rainfall. We're interested in the highs and the lows, when those highs and lows, the spread, temperature. And so for this example here, we have Mānoa. I don't know, has anyone been to Mānoa on Oahu? Okay, yeah, so it's on the windward side, it's very wet. This particular parcel is located a little bit up. So if you know Kalaniana Ole Highway, it's on the other side of Kailua, and it's a little bit cooler, a little bit wet. It's really great area for tree crop production. And then, of course, I'm a soil scientist, and so I really care about the soil type, especially here in Hawaii, because we have a tremendous diversity of soils here. And so that's the first thing I think about is what's your soil type, because that's going to affect how, what I care about, what I'm going to look for, and how to manage nutrients. And so, for example, you can see here that this particular soil is a Kaneohe series. What that tells me is I can look up the description. So it's a very fine ferruginous, isohypothermic, rhotic acrodox. And so that may just be a really long term, but it means something. Each of those components mean. And this is what I can pull from that. So this particular soil is really rich in iron oxides. So that tells me it's a really highly weathered, old, what you think of as a red tropical soil. Actually, this one's a little different. It's not quite red. It's a little bit orange because of the mineral. The particular iron oxide has a little bit of an orangish color. Has very low cation exchange capacity. And so that's important because, you know, we base a lot of recommendations on the nutrient holding capacity, the retention, and trying to make sure that we're able to retain and supply nutrients. There's trace calcium and potassium there. That's because a lot of it's been leached. It's highly weathered. And so we may need to think about that when we fertilize. And then last but not least, it has really high phosphorus sorption. So we call that phosphorus fixation. That means what we add may not be completely available to the plant. And that's because there's a strong reaction that the phosphorus has with the soil that makes it unavailable to plants. And so you can think all of this is going to affect our nutrient recommendations. And then also concerns. We like to think about, okay, well, what other concerns may you have, like environmental? And so, for example, this is near the Kauai Nui Marsh that has tremendous cultural significance. It's also nearby an irrigation canal. So this means we care about nutrient losses. We don't want to apply excessive amounts because that can move off farm and cause problems downstream. And then we can move into the fertility factors. And so this is basically what nutrients we want to manage. So what nutrients are important for the crop production? So as I mentioned, I'm using coffee as a model. And then again, so Andrew's going to come in and then talk about what you're really interested in, which is macadamia. And so, but there's some things that are similar, and so we're managing tree crops. So tree crops are very different than annual cropping systems. So I have a lot of experience working in both annual, well, and perennial, but annual cropping systems. You have very big differences, and especially with respect to time, where we may think about the time it takes months to years to establish the tree, and then moving on to the fast growth, so the years where the tree is rapidly growing, and then to the maturity phase. Now in each of these phases, we may manage nutrients differently to meet the needs, because the nutrient demand's different in those phases. And so, for example, the establishment phase, these seedlings need high nutrient intensity, but maybe not large nutrient quantities. These plants are small. But the reason why it needs large nutrient intensity is because the root system is establishing. So you may not have an extensive root system. So we really care about the intensity, or the amount, the concentration of the nutrient within that proximity to the root, that small root mass. And so it becomes very important. It can't explore necessarily the nutrients that may be available, but may be deeper or outside of that rooting zone. So we talk a lot about intensity, and what this mean or would relate to would be your soil test. You send a soil test out, that the ppms you get back, that would be your intensity. And then for the fast growth phase, so here the trees are getting bigger. And so we have an exponential growth. And so this would generate a high demand for nutrients. We're thinking more in terms of supply. We need to make sure that we have enough nutrients available to meet the demand from the tree. What's important here is we're interested in fertilizing or providing nutrients for, not just what we may think of as like fruit production, but the branches, the leaves, the root system, the trunk. So all of that we may not be measuring or quite have a particular number on. We need to make sure that we're supplying enough to meet that demand, because that's what's going to be feeding the tree later on. And then the mature phase, and so here there's a significant amount of recycling of the nutrients, and so we basically have those structural parts that are present that hold nutrients and then can buffer the plant needs for fruit production. And so for the nutrients, I've provided the nutrient requirements here of 3-year-old coffee trees. What's important here is that these nutrient requirements are yield-based. And so basically it's related to the productivity of the tree. So the lower productivity, the less nutrients it's going to need. If you have higher yields, the more nutrients it's going to need. So it's yield-based. And what I want to show you here is that we have nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. And we have the amount of the quantities of those nutrients in the different parts of the trees. So we have roots, branches, leaves, and fruit for this 3-year-old tree. You can see here that the fruit only contains a minority of the nutrients. So the majority of the nutrients are held either in the roots, branches, leaves. The fruit only contains 25% of the total tree's nitrogen, 17% of the phosphorus, 27% of the potassium, and so on. And so that's why during that fast growth phase that we may not just be focusing on what the fruit needs, we're focusing on what the tree needs to make sure that we have good productivity. And so that's the key difference between the fast growth phase and what you would say with maturity. Now, if it's maturity and you're not having much growth in these areas, then maybe you can just focus on this fruit and think more in terms of replacement. You want to be able to replace the nutrients that you take away. To our knowledge, we looked for several days a few months ago for a table like this, and we couldn't find it. It's really common to find these tables. So here's an example for coffee. California Department of Agriculture has done these tables for avocado, for pistachio, for almonds, and so on. It's not hard to do. and we would know how to do it. Actually am interested in making these tables. What it would come down to is trying to excavate trees and do chop it up, do the partitioning, and then do nutrient analysis. It's been done. It's not too hard, but it would be labor intensive and of course costly. But it's something that I would absolutely love to do. I think it would be it would fill a great need. So I want to talk a little bit about diagnosis too, because that would be the second aspect of this nutrient plan. So we want to be able to actually collect soil samples, tissue samples from your fields and say, okay, from that we want to make a recommendation. So we're going to diagnose. And so for that, I just wanted to go over a little bit of background on soil and tissue sampling. Basically, like, how do we determine whether the soil test or leaf tissue test number is good? And so that boils down to having two basic steps. So we have analysis. This will be done in the laboratory, and then interpretation. And that interpretation is based on some diagnosis that we make. What should it be? What is it? And then recommendation. Well, what are we going to do about it? If it's not what it should be, how are we going to correct that? So those are the basic steps of that. And so here, what I'm showing is a classic, what we call like calibration data. So this is a classic graph of how we come up with that what is good number. And so you can see here, I'm just showing malic. And then we have to have some sort of like outcome or response. And so we have to know, okay, is the yield or the growth or the productivity suboptimal, or is it optimal? And so this is basically our response to how much nutrients in the system. And then from here you can delineate, okay, if we're in this zone here, if your sample falls here, then the diagnosis would be deficient, and then the recommendation would be to apply a certain amount of P or phosphorus. Then you may have a sufficiency range and then an excessive range. And we do care about that excessive range too, because we can actually have problems. We can have issues if there's excessive amounts in terms of productivity as well. And just a couple of things. So as we mentioned, you may get two numbers, Malick 3 and Olson, for the analysis. It matters which one you're getting. And so if you have a soil test that is performed on Malick, if you're going to consult with a recommendation, it's best that that recommendation is made for Malick 3, because they may be on two different scales. And so that's important to keep in mind. They're not equal. They're extracted with very different chemical extractants. They may have different meanings. And then two, so your diagnosis and your recommendation, and how we make that recommendation. What I've shown here is maybe two different approaches I'm going to talk about. The first one would be like a tree demand. And so maybe the replacement approach would be like that. You know how much you remove, you're just going to apply that to make sure you're replacing what you remove. If you're doing the fast growth, whatever the tree demands, that's what you're going to use as the basis of your recommendation. The second approach, though, is the soil deficit. And so that's trying to say, okay, my soil test is here. I want to get it to here, to this point. How much fertilizer do I need to add to bring my soil test? This is why it's important to know soil type, because your soil type is going to influence what I may recommend. So I may use, sort of equations or formulas based on your soil type to then make that recommendation to bring you up. And I'm going to show examples of this too in just a moment. And then I also want to mention too, so I gave you an example for Malick 3, so that's your typical soil fertility, but I also do want to talk about soil health today. And so I do care about organic matter and other maybe soil health measurements. We can do the same thing. So it doesn't just have to be a soil fertility test. It can also be a biological or physical test to give us an idea of our soil health. And we can go through the same processes where we may have a diagnosis, degraded, a grading, maintaining soil health, and we may come up with recommendations too. So I wanted to provide an example. And so here is the actual data that we got back from that Mānoa orchard. And so this is very typical of what you may see from like a Brookside lab. So we have cation exchange capacity, pH, and then we have our nutrient analyses. And we also have aluminum too. because although it's not a nutrient, we do worry about toxicity. We don't want too much aluminum. And so here's the results. And then when it comes to the diagnosis, we have data that's been previously collected. And so this would be like UH, or you would find this in like CTAR UH, or some crop consultant that's where there's work done with this. And you can see here the diagnosis, very low pH, and anything in bold here, phosphorus, calcium, magnesium, potassium, and then zinc, those are all very low according to the soil test. And so immediately, okay, we need to keep those in mind to manage those. All right, so you can see that there's a lot to watch for. And also too, you'll see we may not be managing all of these because we have tissue testing. And so tissue testing here, we want it to be complementary. And so you can see here that these are optimum leaf nutrient levels for coffee. And then we can look at tissue data. And so this is actual leaf tissue data here. And you can see here, so here's an example where only zinc is deficient. So unlike our soil tests that were deficient in quite a few, only zinc are. Just keep that in mind because this is important moving forward. Okay, so now we're going to talk about making a recommendation. And so that's basically going, okay, now we know what we need to look for. We need to know what's important. Now how are we going to determine that rate that we need to add? And so for this, I want to go back and talk about the phases, because as I mentioned, management and therefore our rate, how much we add, may differ depending on what phase we are in production. So we have the establishment again, the fast growth with exponential rate, and then the mature phase with a lot of recycling. If I'm in the establishment phase, I'm going to pay particular attention to that soil test, because I talked about intensity. The roots aren't really extensive, and so they're really reliant on how much nutrients available in that soil solution. And so I'm going to care about phosphorus, potassium, calcium, magnesium, and zinc. Those were all that were deficient. I'm going to pay particular attention because I want those plants to establish and grow well. Fast growth. So this is more in terms of soil in supply. So maybe your concentrations may be a little low, but you have really extensive roots. And you maybe have a different rooting depth. So overall, we think more in terms of supply. How much, even deep in your soil, how much is becoming available to your plant? And then we also want to match that with total plant growth. So we go back to that table. So not just what the right fruit's removing, but the whole plant, the branches, the roots, the leaves, the fruit. And then here, I want to pay particular attention to nitrogen, potassium, and zinc. Nitrogen and potassium I want to pay particular attention to because we're going to look at the table. They're required in really high quantities. And that's common for tree crops. We worry about nitrogen, we worry about potassium. And then zinc, because of tissue testing. The tissue testing is saying, okay, the leaves are telling you that they're below suboptimal levels. And then in the mature phase, there's a greater emphasis on the tissue testing. I hear a lot of you tissue test, which is great. Here, for recommendations, we may be talking about nutrient replacement. You don't want to take away more than you add. For nutrient balance sake, you don't want to mine your soils of the fertility. And then here, if we're focusing on tissue testing, zinc may be what we pay particular attention to because of the leaf. So I want to show recommendations that we made for nitrogen, phosphorus, potassium, calcium, magnesium, and zinc, and go through some of these recommendation steps. And so, as I mentioned, so this yield was 1,410 pounds per acre per year. So what I did is I used that previous table and I just scaled it up. If you remember, that previous table was 1,000, just scaled it up because it's a little bit above that. And so here, for that total, if I'm fertilizing for total uptake, it's 158 pounds of nitrogen per acre per year. And then here, you can notice too, ripe fruit, if you're just fertilizing for ripe fruit, it's 46 pounds of nitrogen per acre per year. And so as I mentioned with nitrogen, you can see here that nitrogen and potassium require a lot. And so I'd want to make sure that you were providing enough nitrogen. Also too, nitrogen is very mobile in the soil. Nitrate leaches, and so it's good. It has lower reactivity with the soil particles, and so I would, focus on the nutrient need for nitrogen particularly, which is also why I didn't focus on soil testing for that one. Okay, for phosphorus, so I mentioned before, because of phosphorus sorption or phosphorus fixation, we care about the soil series. I mentioned this has a high fixation capacity. So basically we have a critical P level that the coffee tree must have. This was done by CTAR researchers, and then I need to make that up. And when I go through these calculations, then you have the predicted amount of phosphorus is about 30 pounds per acre. Now what I want to do is compare this with the plant need. Because I want to see, okay, so this would be good for establishment phase. I want to see how it compares to that fast growth phase. You can see it's about the same. And so I feel pretty confident within each of those phases. So 30 pounds per acre, that meets or exceeds that 25 pounds for that need. Okay, for potassium, so here you can see that the plant need is 177 pounds per acre. That's actually more than the nitrogen. Nitrogen was 158, so it has a higher demand for potassium. And then for soil deficit, so the soil test said 140 ppms. In order to use that second approach to make it up to that sufficiency level, we would need to add 215 pounds per acre. And so if we go for the soil test approach, we meet the high growth needs as well. Okay, calcium, magnesium, this is where it gets really interesting. Because here's where, you remember these soils were really, they had trace amounts of calcium, very low in magnesium too. And so here, if we go by what the tree needs, we have 51 pounds and 21 pounds per acre for calcium magnesium. But then when you look at the soil recommendations based on soil tests, they're very deficient. And you can see that the recommendation would be 1,345 pounds of calcium or 330 pounds per acre of magnesium. That's a huge disparity. And so this, if we just apply this, this may be a concern for the establishment phase. And so it's just something to keep in mind. What we ended up doing though is another route. And this has to do with the pH. And so Julie wanted to raise the pH from 5.0 to 5.5, and that was recommended. So she added half ton of dolomite. That would take care of and equate to 625 pounds per acre and 375 pounds per acre. That is more than enough for what the tree needs, and not quite as exorbitant as what the soil test needs. So it's kind of a compromise.
She's killing two birds with one stone.
Exactly. Yep, she's taking care of a fertility issue by addressing the soil acidity. And then she had a recommendation. There was little data on this, and so she found a recommendation for 4 pounds per acre for zinc. And then she is going in and looking at monitoring to see if she got a response in the leaf tissue for zinc. So here I have a nutrient budget. There's nutrients in the system that become available too. And so we have estimates. We're crediting our soil, as well as if you have like a legume cover too, you want to credit that. So this would be our soil organic matter for nitrogen mineralization. We're crediting that. And so here, this particular soil, we could expect 63 pounds of nitrogen per acre that's mineralized within that year. And then she's going for the organic market. And so she has organic inputs. She made it on the nitrogen basis, and then she calculated out how much phosphorus that would supply, how much potassium that would supply, and so on and so on. And then for phosphorus, it exceeded that. You got to be careful with phosphorus too, for that reason, for organic. It's because you typically apply more phosphorus if you do it on a nitrogen basis. And then you can see at this point, this was not needed, but potassium was. And so she used an organic approved mineral form of potassium to meet up that demand. But yeah, the blends can be tricky. I've done work on, one farm, there's like 5 blends that are being used, and you just have to do kind of a complex budgeting. I think there may be some competition, or even a lot, but also too they're also adding organic matter, and that will start building and recycling. Like grasslands have some of the highest soil health out there. And so,
but does that get taken into account? Is it significant enough to have to be taken into account? Just the opposite of a cover crop.
Yeah, and so, and that's an interesting point too, where, I've worked with no-till systems where you convert to no-till and they have a debit. So you add a little bit more fertilizer because you know you're going to have a mobilization. But what you see is with time, so if you've been doing it for, like a decade, you reach some sort of equilibrium too. And so you have to, there's...
You mean the return from the
yeah,
grass
kind of
equalizes?
Equalizes. I'm not too sure about the grass, but I've never studied one in that system, but at least with the no-till, with that mobilization, which is the same phenomenon that you're talking about here, it kind of reaches this level where you no longer have to debit. You just treat it like as a system in equilibrium. And so the last thing I wanted to talk about before passing it off is just soil health. So speaking of soil health, so if you do start building your organic matter, you'll expect more mineralization from that soil. So I work with the team. So here are directors for the project. I just want to acknowledge Dr. Susan Crow and Jonathan Dienick. We're part of the soil health team, and so your samples are going to be part of our program. We're in research and development of the soil health tool. Your samples are also important because they fill a very important gap in what we have. We're looking for soils in this on Hawaiʻi Island with tree crop systems. And so we want to have a wide range of soils. We want to understand soil health here, and we're happy that you're helping us do that so that we can come back and give you good interpretations of what your soil health means and suggestions or recommendations for how to improve it. Healthy soil has, first and foremost, I put at the top, sufficient nutrients, but not excessive. We don't want excessive nutrients, but has sufficient. So we're talking about high nutrient supplying capacity. And of course, it's not just your nutrient availability. We're talking about our physical properties, so soil tilth, water storage, drainage, and then our biology. So beneficial organisms, we want abundance, we want diversity, and we also ultimately want the soils to have all of these good properties to be resilient. And so you can see here, what I've talked about so far has been a lot in the chemical. So when you send a soil test off to a laboratory, it's mostly measuring the chemical properties. All these things will be familiar from your typical soil test. But we also care about the physical properties. And these are different measurements you can take for that, as well as your biological properties. And there's also measurements you can take for that. And at the center of all of this, the centerpiece is soil organic matter. Soil organic matter improves your physical properties, and it improves your biological properties and your chemical properties. And so it's very central to soil health. I just wanted to give you a little bit of a background on the development of the soil health test, particularly for those who are either submitting samples or may want to submit samples. And so why we're doing a soil health test is because we need one specific to the islands. There are other soil tests out there that you may, if you Google soil health tests, Cornell has a popular one. But the reason why we need a specific one is because they have to be calibrated. We have very unique soil types here that you're not going to find on the continental US. And very, very unique management systems. And you represent a very unique management systems, all of you. And so it needs to be, this test needs to be suited for these two items. And then also it needs to be locally adapted. So what I mean by that is the assessments. We need measurements that work here. There's an example, a common one, Active C is common on the mainland. It uses a manganese or permanganate that has manganese. Some of our soils have manganese oxides, so it doesn't work. And so we can't use that test. We have to use something else instead. Also interpretation. So on the mainland you hear about soil texture a lot. Here we think about mineralogy. We think about whether or not you have aluminum iron oxides, or if you have low activity clays or high activity clays, or histosols if you're in the organic soils, whether it's on A'a or Pahoehoe flows. And then recommendations. So we need it to be, again, locally adapted management. And so just to give you a really brief background, we have the development is in terms of soil sampling, and then testing the indicators. So there's 44 indicators that were tested. We selected 11 of those because we can't run all 44. We tested selected only the ones that were good for here. And then ultimately, we want to come up with a soil health score. That's where your samples are really important because we want to make sure we have the full spectrum of Hawaii samples. So these are the core. We're building this out, but you can see the original set of samples. We have no samples from here. And so we have a big, huge geographic gap. And then we select the indicators. So I mentioned 44 indicators, but I'm going to show you the set that's narrowed down. We want the ones that are most sensitive. They make sense for sensitive to management changes, that's reproducible. We want to be able to do the same test again and get similar results. We want it to be feasible. We don't want a test that takes 3 months to perform. We need a test that can be done routinely. It's cost effective and time effective too. And so here's the list. So someone asked earlier what tests we would run. And so these are the tests. So we have organic carbon. I mentioned that's the cornerstone or the central point of soil health. And then we have 3 biological indicators. So we have respiration, we have a couple of enzyme assays, and we have potentially mineralizable nitrogen. So that's really important for nutrient management. And then our chemical test, pH, dissolved organic carbon, dissolved organic nitrogen. So that's a bioavailable form. And then hot water extractable carbon, that's available to microbes. And then our physical, so water holding capacity, mega aggregate stability, so that gets to how your soil structure, as well as bulk density. So here's a little bit of a function. I don't want to go into these each, but we have materials where you can read about these more in depth. Just the takeaway point from this is each and every indicator has a meaning, it has a function. It's unique within itself, and it tells us something about the soil that's useful. So they each have different functions. But I just did want to highlight these because I do want to relate it back to nutrient management. And these I find very useful because you'll see here that these are enzyme, 2 of them are enzyme activities and mineralizable nitrogen. Both of these, a higher value indicates nutrient availability, nitrogen cycling, and nitrogen cycling that could be useful for productivity or to support productivity. So essentially, this goes back to here. And so if we're building soil health, the soil and the soil credits we can factor that in and reduce your fertilizer requirements if the soil is able to supply more. And just real quickly, cultivation, of course. You're in tree systems, so it's a little bit different, but when you till, you cultivate, you can lose soil organic matter. And ultimately, we're trying to find practices where you have a grading, not degrading soils, but grading soils. And I just wanted to throw up this slide right here because this does pertain to tree-based systems. And this is the last slide where we want to look at these different practices that would increase soil organic matter. So if it's alley cropping, annual permanent, reduced tillage, organic fertilizer inputs, all of these in this particular study increased soil organic matter. This is a meta-analysis, which is like a summary of lots of experiments. And then fruit yields, you mentioned competition. And so this is where you may have both negative and positive effects on fruit yields, but overall, on average, which is where these points are right here, there was really no net negative or net positive effects. So the conclusion here was, you could do these, build organic matter, but it wouldn't necessarily negatively impact your yield, and that's the goal.
Aloha, I'm Andrew from Island Harvest. Today we're going to be talking about macadamia orchard nutrition. I've had the privilege to be able to learn from a lot of other people and from just kind of the research out there and from experience with this macadamia nut farm and try to bring that together. And so today I'll be presenting just kind of more specific on macadamia nutrient management, and hopefully that'll kind of help inform people's decision makings and kind of get a conversation going within our Hawaiʻi Macadamia Nut Association about what's best nutrient management practice so we can all be improving and delivering and selling and eating good crop. I'm going to have a lot of tables, but I would say, unless I point it out, just kind of pay attention to the overall concept. There's 16 essential plant nutrients, and we kind of break those into macronutrients and micronutrients. So, NPK, nitrogen, potassium, phosphorus, or nitrogen, phosphorus, potassium is kind of what's talked about as macronutrients. And then you have all those micronutrients. So there's all these other ones that are essential to plant growth, and they're also essential to macadamias, but in very differing quantities. So for macadamias, just like a quick nutrition overview, the most needed nutrients for macadamias are nitrogen and potassium. So those are the highest things, and that's largely a function of it's needed for plant growth, right? The nitrogen particularly, and for some of the husk development and kernel development. And then potassium is especially needed particularly for your kernel development. So potassium is really needed at a specific time in the process at higher amounts. Now, things like calcium, magnesium, phosphorus, and all those micronutrients, those are also critical, but they're just needed in lower quantities. And so there's this law called the law of the minimum, which means your yield is proportionate to the amount of the most limiting nutrient. So although nitrogen and potassium are needed in the highest quantities, if you have a deficiency or a toxicity in something else and you don't address that, even if you're putting on just as much nitrogen and potassium that you need, or you have a system that's able to provide those nutrient needs, you might be limiting your yield. And so that's why I think we'll talk about soil and tissue testing. But being able to at least look at that frequently, semi-frequently, I think some farms are doing it, multiple times in a year. That helps to show you even if you're addressing nitrogen, potassium, and maybe calcium, magnesium, to see if there's something that could be limiting your yield. And obviously this presentations, we're talking about nutrition. There's other things like disease, Phytophthora, we all know about, things like that also can be limiting. And they're related to nutrition, but for today, we're mostly focusing on nutrition. This is just a nice little kind of calendar. It came out of Australia, and it's something that we print out and put it up on our wall, and it just shows the timing of things, of nutrient needs. And so January, February, March, you're getting peak flowering, right? And December. And then you start to get some spring flush. And so you're needing nitrogen during that time, right? Right now, all of us probably have crop that's starting to fill out. And for the past couple months, it's needed potassium to be able to fill out that crop. And so I would say especially with potassium, and then sometimes, magnesium, calcium as well in smaller amounts. Those are kind of critical if they're limited during kind of these past couple months leading up to the crop cycle. You could be leaving yield on the table if you're not addressing those nutrients. Nitrogen, for the most part, is kind of needed throughout the year. There are peaks and troughs, and then there's also differing opinions on that. But in general, most people say to kind of split up your nitrogen applications multiple times a year so you're not shocking the tree with too much nitrogen. I think one thing that's really important for all of us is using soil and tissue sampling, like Tai talked about, to inform kind of our nutrient management decisions. The soil tells you kind of what's beneath the tree, and then the tissue really shows you what's being taken up. So like Tai was saying, there's a deficiency in one thing in the soil, but it might not necessarily be limiting the tree. And so we can kind of look at both of those side by side. It's really important to be consistent with your soil and tissue sampling. So you want to do the same methods, kind of try to get representative samples of your orchard and do them consistently, at least yearly. I think some people do more, especially for tissue. For tissue sampling, what you're looking for is a newly flushing branch, so a new branch that's fully flushed, and you take the second or third whorl. So there's usually 3 leaves on a whorl. So the second one down or the third one down. I think we usually take third one, and then we just stay consistent. We always take the third whorl. Don't go between second and third. Try to just be consistent so that the data you're collecting stays the same over years. And then for soil, over the years, we've mostly done soil sampling with a shovel. You scrape away the top layer of like organic matter, and then you try to get like a wedge that's about 6 inches deep, which is like kind of about where like the main feeder roots for macadamia are. We recently purchased one of these. Ty told me about it, and it's pretty awesome. It's like a fence pounder, and it's called a slide hammer, and it goes into the ground, and you can get pretty much, you know, exactly 6 inches or 8 inches if you want 8 inches. And so it's a nice little tool. And we can, yeah, when we go up into the field, we can kind of show how it's used. But yeah, I think try to be as consistent as possible. And then the other thing is, like, different people have different sampling methodology based on what they want to do, right? So like, you can take 500 samples of tissue tests across your farm and you'll know every little thing across your entire orchard. But if you can't apply fertilizer that way or address it, it's not really like a concern. So like we have about 750 acres. We take about 7 to 12 soil samples, and we take composite samples from each kind of field. And so we'll take like 5 to 7 subsamples of soil and mix them together to create a composite sample. So we'll take it from, you know, more near the middle of the row, like near the tree, like a few feet away from the tree, all where we're fertilizing and where the tree's feeding from. We mix that into a composite sample, and then that's for that field. And then we do the same thing in that same area where we took that soil sample. We'll take tissue samples from all the same varieties of trees. And so we do 3,4,4s, which typically sometimes show higher nitrogen levels. People have different opinions on that, but we take all from 3,4,4s in that same area, take it from different trees, third whirl, put in a bag, and then, you know, label it the same as the soil, so we can see this is what the soil was in this field, this is what the tissue was in this field, and then try to make a decision. Leaf samples should be taken in the spring, probably later than that. Okay. We want it once the crop is starting to develop, March through May. We typically just sample once a year, and we kind of go in the middle, and then try to compare it year to year. And then this is just an example of what a soil test, like this is one of our soil tests and what it looks like. A crop consultant can give you the estimated optimum ranges, and there's some debate, especially for soil, about what those are. And then you have all your fields there, and you kind of can see where you're deficient and where you're sufficient. And then we also, organic carbon, organic carbon and soil organic matter are kind of the same thing. They're just two different ways of representing that value. And so that's something I'll talk about later, but soil organic matter is kind of a big portion of how we look at our nutrition. And then you have tissue tests. And tissue tests are, I would say for the macadamia industry, are kind of more dialed in. I think most people agree, and there's good resources on, you know, what optimum concentrations of each nutrient in the leaf. They've figured it out so that if nitrogen's below a certain one or potassium's below, it can really decrease yield. So kind of looking at those tissue samples and looking at if you're within those ranges is a pretty good way to figure out, you know, what you're missing, or even some excess. There's certain things that can be in excess can cause issues. And this is an example tissue test. So right here in this field for nitrogen, it's high, it's 2.45, and the optimum range is 1.4 to 1.6. And so that might tell us that we have excess or at least sufficient nitrogen, and we might skip an application of nitrogen in that field, you know, if that's kind of verified with what we're seeing with our eyes and things like that. There's a couple that were excess in there, and then we have deficient potassium in these two fields here, and we might add a little bit more potassium to our fertilizer regimen for that year in those fields. But we tend to take like at our farm, kind of a longer term approach, and we aren't too reactive, but we try to follow trends over time. One of the ways in which people kind of try to determine fertilizer rates and like how much to put on has been how much you remove, right? Especially once you're in that mature stage, like Tai had mentioned. And so this is just a table that shows for 100 kilograms of wet and shell with the husk on, how many grams are being removed of each nutrient. And I was gonna try, I didn't have time to convert everything to like pounds per acre, but I think the biggest takeaway from this slide for me is just look at how much the husk has 212 grams of the total 405 grams of nitrogen in it. And then also potassium, it has 280 of the total 333. So that husk contains a ton of nutrients, and it's needed for, like, you need to have the husk in order to produce the fruit, but also you have an opportunity to put the husk back onto the orchard. So if you're removing the husk and the shell and the kernel, like, you're probably creating more of a deficit than if you are either returning the husk to the field or like on our farm, we try to use mechanical harvesters that dehusk in the field so the husk is left. And that, it puts it in the middle of the row, not near the tree. It has its own issues, but I think one thing that, everyone can have a different way of trying to address that. But I think it's important to point out just how much of the nutrients are contained in the husk. This is from Mike Nagau's paper in 1992. These numbers are a little bit different than what we've seen out of Australia and South Africa in recent years. And so paying attention to these absolute values might not be a good idea. Like Tai and I discussed that we're not really sure exactly how they came up with these and who's right, but the concept of a lot of the nutrient is in the husk, I think is a good concept to kind of be thinking about. And then this is a table out of Australia that shows how many kilograms per hectare are needed at different yield levels. But again, this is without the husk. So like this, if you're leaving the husk in the field and you're just removing the shell and the kernel, this is how much would be needed at 2 tons, 4 tons, and 6 tons of yield per acre just to replace that crop. And so something to kind of just point out here is you look at your order of magnitudes, nitrogen and potassium, if you're doing 6 tons per hectare, you're removing 82 kilograms of nitrogen, 66 kilograms of potassium. It's a pretty significant amount. Phosphorus, calcium, and magnesium are removed at quite a bit smaller amounts. So that was crop replacement. That's just how much you're like removing that you kind of need to account for. But like Tai was mentioning, we don't really know, we don't have good numbers in macadamia that we know of that account for how much the tree needs at the different stages of growth. Like we know in general that nitrogen is needed for tree growth, like for good tree growth, and there's some recommended rates out there, but there's not like really kind of hard science that we found that shows at years 0 through 3 the tree needs this many pounds, at years 3 through 6 it needs this many pounds. But however, most of us are dealing with mature trees, and at that point the growth is it has slowed. It's still necessary, and a lot of us tend to look at crop replacement as the way to kind of determine fertilizer. So we've talked about kind of how much is being taken out of the system by crop removal, and then we'll talk about a little bit of tree growth, and then to come up with like your nutrient management decision, we need to meet the needs of the plant and the crop. And kind of traditionally, we kind of go to fertilizer. I think most people is like, oh, we need to meet it with fertilizer. But there's other ways to provide nutrients to your system other than fertilizer. Soil organic matter, which is built up through mulching, cover crops, compost, continual mowing, and can be depleted by tillage, leaving the soil bare, erosion. Soil organic matter can provide a ton of nutrients, especially for macadamia, which isn't like, it's not it doesn't have as high nutrient demands as some other crops like, you know, vegetable crops or things like that. And then you also have biological fixation, and this is something I think is a little bit less well understood, but it ties into soil organic matter. If you have a healthy soil, there's potential for fixing nutrients, and also like cover crops can fix nitrogen is something that, you know, people know. Yeah, trying to credit those into your system can be a little bit difficult to like figure out how much it's supplying. So I mentioned that soil organic matter, so this is kind of outside of, I mean, organic fertilizer can help build soil organic matter, but a lot of this is kind of your cultural practices and maybe composting and things like that. It can provide a ton of nutrients, potentially, in kind of an optimal system. And so I wanted to point this out. This is some data from some trials that UH did that from different soil series about the potential mineralization of soil organic matter that can be for nitrogen that can be provided to the plant. So if you look at just, you know, UH trial 1, the Wahiawa series, soil series, they determined in one trial that 86 pounds of nitrogen per acre can be, like in optimum conditions, can be supplied through soil organic matter. And if you build your soil organic matter, it could potentially be more. That's a pretty significant amount. However, the kind of the catch is, like, this is done in a laboratory, and it's kind of under perfect like water and temperature conditions. And so like right now here in Kohala, it's so dry, we're probably not getting much from our soil organic matter. We're probably not getting much from fertilizer either because it's so dry too. You need the water. So in that sense, like, we're probably not getting much nutrient needs, but if we have kind of steady rainfall, and I think Mac Farms is a good example of this, like in the past couple years, they've had, and correct me if I'm wrong, Mark, but this is what Nathan told me, Dan said. Like in the past couple of years, they've cut back their nitrogen fertilization like almost completely in some instances because of the rain. And why is the rain giving nitrogen? I mean, part of it might be that it's mineralizing some of the existing fertilizer, but I think a big part of it is probably because it's a dry area traditionally, but there is soil organic matter. The rain comes, the temperatures are good, and it supplies.
Some soil scientists, when they see our organic matter percent, they freak out because it's so high.
Yeah.
But that's what I think that's correct.
And so this is a calculation I did for our farm, and it was based on 10% soil organic matter. Usually 5 to 10%, like here in Hawaii, is, you know, good. If you're at 10% soil organic matter, you know, this is just the calculation, but you can get 172 pounds of nitrogen per acre just from that soil organic matter, potentially. You know, 1/3 of that, which might be a better estimate of like how much you'll actually get, is like 57 pounds, but that's still a really significant amount. And so paying attention to those things might really change like how much fertilizer you really need, and might, you know, you might change your management method to build more soil organic matter because you're getting all those benefits. And then, you know, you don't have to ship in as much fertilizer. And that's something that we focus on because organic fertilizer is expensive. This is some of the fertilizers that we use, meat and bone meal and they have that from like Oahu, or feather meal you have to ship in. And it's 9% nitrogen, that first number, 11% nitrogen for the feather meal. And then just a comparison, like urea, which is like conventional synthetic fertilizer, is like 46%. So it's like, you know, quite a bit more. So when I'm saying like, oh, we're removing 60 pounds of nitrogen, I'm talking about not 60 pounds of fertilizer, it's of the actual element of nitrogen. So if you're putting on a fertilizer that's 11% nitrogen, like you need 100 pounds to get 11 pounds, 100 pounds of fertilizer to get 11 pounds of nitrogen. And then with that, not even all of that is able to be taken up. Usually we assume only about 70%, and it can vary greatly, will actually be taken up by the tree. So when you're figuring out how much nitrogen you're applying, I just want to make sure people understand like those numbers are the percentages, so that, you don't under apply. And then I just have some like other fertilizers that we sometimes use especially for potassium. I'll just point those out. Or if we have deficiencies in things. For potassium, I think a lot of people use K-Mag, which provides magnesium and sulfur. It kind of provides a lot of magnesium and sulfur though, and I I'm just gonna just say my opinion. I kind of question why some macadamia growers use so much K-Mag, because there's not that much, unless they have deficiencies of those things. Like, I don't think it should necessarily be the go-to for potassium. Whereas when you can get sulfate of potash is at least it's higher potassium percentage and lower sulfur, but that's just kind of if you need magnesium, obviously that's a good one to go with. Just really quickly, this is compost, a sample that we did that had 47% macadamia husk, 47% dairy manure, and I think 6% calcium carbonate. And then you look at the NPK values, 0.71, 0.47, 1.05. So for every pound of that, you're getting so much less than a fertilizer. But you put that on at a ton per acre, it's actually relatively cheap, but it's expensive to apply, and it builds soil organic matter. It is a good way to provide nutrients. And this stuff tested at 8% pH if you have acidic soils, in addition to calcium or liming to bring up your pH. Compost and organic matter can help buffer against some of the low acidity things. And then I just wanted to really quickly point out carbon to nitrogen ratio. So people like to apply wood chips, and just to give just so that people know, if your carbon to nitrogen ratio is above 30 to 1, so wood chips, and this is from a study that Russell did on our farm, he applied wood chips, and wood chips are almost they're over 100 to 1 carbon to nitrogen, so they have so much more carbon than they do nitrogen. That can actually steal some nitrogen away from your soil. So if you apply a bunch of wood chips, and this is what Russell did in his study in our orchard, we actually saw nitrogen levels drop a little bit in the subsequent year because it was competing with that. It was net immobilizing. However, there is a long-term benefit to that, and it might be worth it, you know what I mean? And if just something to be aware of. Whereas if your carbon to nitrogen ratio of your amendment is less than 20 to 1, it's going to be net mineralizing, so it's going to be adding, particularly important for nitrogen. Just some application equipment. We have one of these. It's an orchard deflector. It's a fertilizer spreader that shoots the fertilizer out into the orchard. That's some ways you can apply. One thing we're not talking about today is foliar fertilizers, and we do quite a bit of that because we think there's some biological and enzyme benefits, and you can also get out and spray a little bit easier for us sometimes instead of bringing in a container of fertilizer. So we do a lot of that. This is a compost spreader. We do some of that during the off season. That's an ATV version of a orchard spreader. And then some of the bigger farms will do applications of nutrients with a helicopter that has a fertilizer spreader under it. I think Mac Farms and Hawaiʻi Mac Nut Company both sometimes do that. This is just a spreadsheet that I made that tries to budget out how much is being removed, how much is added through soil organic matter. And I have to revise this. This isn't it's kind of a working thing, but that's something you can do. You can create a spreadsheet. You can figure out how much your yield is. You can figure out how much is being removed, how much you want for the tree, how much your soil organic matter is, and then come up with a decision on how much of each nutrient to apply, and then use soil and tissue testing to inform that. There are also kind of recommended rates out there, and this is something that I just kind of put together kind of as a rule of thumb for ourselves. I'm not recommending this, but early on, when you're year 0 to 2, 3 to 5, 6 to 8 of a newly planted orchard, you're really looking at the tree growth. How much does the tree growth need? And you're looking at mostly nitrogen and not potassium for macadamia nuts. And then once you get 15 years plus, and you're doing 4,000 pounds an acre, which is definitely kind of above average, and you want 5% tree growth, this is kind of my estimation of how much pounds of nitrogen and potassium you need in that system. So at 4,000 pounds an acre, 5% tree growth, it comes out to about 81 pounds of nitrogen that's needed each year in that system, and 44 pounds of potassium. It's a rough calculation, and then with that, then you have to decide how much is your soil organic matter adding, how much is your fertilizer going to add, and all of those things. And that's and then what does your tissue test say? And then you go out and make a decision on fertilizer. So that's kind of one way that that we've looked at it. And I just want to talk about toxicity and deficiency. So deficiency is whenever it's, like below those critical levels. Toxicity can happen when certain nutrients get above some critical levels in macadamia. One common one that we see in Hawaii is phosphorus over application, so getting buildup of phosphorus in your soils, and then that limiting, phosphorus has an interaction with iron, and if it sometimes can create iron deficiency. So too much phosphorus can create iron deficiency. So, be looking out in your orchard for things that look really weird like that. And some people know how to identify it right away. I'm not very good at it. Nathan's pretty good at it. But that can be a sign of a deficiency, and that's what iron deficiency looks like. And then you can have toxicity, and manganese toxicity can happen, aluminum toxicity. Those are some of the ones that happen. We planted some young trees and we saw manganese toxicity, and then we took tissue samples and the manganese was like over 2,000 parts per million, and we're like, oh wow. So that's something to keep in mind, looking for toxicity and deficiency both on your tissue tests and in your orchard. This is pH on the bottom here, and this is like availability of plant nutrients here. And this is a really nice table to kind of help you understand, like if your pH gets too high, you might have more availability of phosphorus and low availability of iron, and that might also play into your phosphorus-induced iron deficiency. And then like manganese, if your pH is too low and you have a lot of manganese in your soil, it can create manganese toxicity maybe. And that's what happened. Our pH was a little bit low and there was a lot of manganese in our soil where we planted this new tree. We saw manganese toxicity, and then our decision to try to change that was add calcium, which helps in more than one ways, but one of the ways is it raises the pH. And if you raise your pH, it can mitigate the effect of manganese toxicity. But anyway, I'm not going to get into like all of that, but those are some of the things the interactions that we're looking for that could be causing problems in the orchard. Generally in Australia, they're recommending about 100 pounds of nitrogen per acre, and there's farmers that do up to like 200 pounds of nitrogen per acre. And there's been studies that showed the over-application of nitrogen can affect kernel yield and quality. We don't want to over-apply, you don't want to under-apply. And just to kind of give you an idea that in general, I think Australia and South Africa, they're applying more than we probably are here. And that might be because we have more soil organic matter we don't need to. So it's not like, don't just look at what Australia says and say, I'm going to do the same thing, kind of. We inundated you with information and some key takeaways that you can like kind of hopefully go back to your farm and make some decisions and try to take soil tests and tissue tests annually, or at least once, maybe after this workshop, and kind of see where you're at and see if there's anything that jumps out at you that's like, oh my goodness, this is crazy. Try to measure how much crop you're harvesting, like per field or per acre, so that you know which fields are producing more, and try to figure out like why and if nutrition is part of that. And then determine kind of what you want to decide what your fertilizer timing rate and application method is going to be. And then observe the tree response, take the soil and tissue samples again, and then, adjust to try to do that. And then also monitor for toxicities and deficiencies that could be causing either yield loss or visual like growth issues. And then the other thing, and I'm kind of a soil organic matter stan now, like I'm kind of like really believe in it, and like nutrition comes from a lot more than just fertilizer, and there's different ways to address your nutrient needs, and not everyone needs to follow the same plan. And soil organic matter is one of those ones that I think can play a big role, especially for us with macadamia. And it builds the life of the soil, builds biology, and does other things than just provide nutrients. So, don't just focus on fertilizer, kind of focus on everything. So.